I know it has to go over the Zoom as well. So Abdul Majid will be presenting the talk on peering into space with the Moroccan Outrun Observatory. Thank you.
Thank you, David. Good morning all. So I replace my colleague Zuhair Ibn Khaldoun dans his presentation, which entitled, thank you. Peering into space with Outrun Observatory. So let me introduce myself. I'm Abdel Majid Benida, Professor at University Kadaidat, colleague of Zuhair bin Khaldoun. I belong to High Energy and Astrophysics Laboratory, which contain two teams, High Energy and Theory, and Astrophysics and Astronomy. The monitoring of Outrun Observatory. So I will present you some work, and I hope that with this presentation, you will know better our observatory of Outrun. So let me begin with the outline. I will do the best because I have a lot of the slides, and given the time that I had, I will try to respect the time. So I apologize. In the beginning, I will introduce Outrun Observatory, and I think I will focus especially on international program, and I will talk about main discoveries, and I finish by Atlas Dark Sky Reserve. So let me introduce the Outrun Observatory. Is about 70 kilometers south Marrakesh, which is operated by University Kadaidat, have been inaugurated in 27, is located in High Atlas mountain at elevation 2,750 meters. It benefits from good observing condition.
That's what they say.
The value of median stream is about 1 arcsecond. So, a brief history. There are a lot of moment and important event at history of Outrun, but I will only talk about many of them. Like I choose, for example, when Morocco has selected for ALT site 16, and the first program MOST telescope installation, when we started the variable star program with the spectroscopy at the main dome. Perhaps if I have time, I will run one and installation of the OWLNet telescope with the Korean Space Agency, and I finish with the famous TRAPPIST-Nord telescope. So let us begin. So I will skip many slides to give the main. So we can. I can say that after deep characterization of Outrun site, we can conclude that the Outrun Observatory has a median state about 0.9 arcsecond, with frequent peaks at 0.5, 0.6 arcsecond, which are very good climate statistics, especially in terms of the number of good photometric light, about 3,000 per year. So now I will talk about that about the ACLIM qualification campaign, because our group continue to work in site setting in this area. Morocco indeed has chosen with 4 countries to be a site of ALT telescope, as Argentina, Spain, and Chile. So the site of ACLIM is situated in Anti-Atlas, near the city of Agadir in the west of Morocco, and is altitude about 2,050 meters. It was between date between 2009 and 2006 and 2009. It's really, I have contributed to this mission. It was really a special human experience, because we meet people in this village. They are enthusiastic to have like this program. So we have asked to help with the military, because they are very difficult to access to the site in ACLIM, and it was a virgin site. So we have this experience led us that confirm our experience in site testing. And although we had not chosen to lead the LT telescope, it's finally Venturones in Chile, which has been selected, but we have a long experience in site testing. So it was the initiation for the program international in Oakhampton. There are some publication on the Astronomy Society about this experience in ACLIM. And now I go directly to the international program leads in Oakhampton Observatory. We can see a small body of the solar system, variable stars, space weather, with runoff facility, and the main program about exoplanet and comet by TRAPPIST. So let us begin by the famous one, and the first one, who's called Moroccan Sky Survey Telescope, MOS, acronym MOS, is a telescope with 50 centimeter, and observe, yes, it's charged between observation of exoplanet transit and asteroid and comet research. It's starting from 2011, and after there are some MOS send more than 1.5 million astrometry measurement to do MPC. So thanks to this program, the Oakhampton Observatory recently integrated the top of 50 best observatory among the world. Indeed, you can see here interface of software and the site of the MOS in Oakhampton, the dome in Oakhampton Observatory. In the right, you can observe the interface of software that you use in this program, and in the left, the main discovery of MOS in 2017. So we have 4 comets, 5 new and minor planet. Shall we go? The next program is spectroscopy forum. It's my thematic, my field of research. So I will develop it this afternoon. Though I can say that only that we lead many campaigns of spectroscopy measurement to variable star, to study variable star like RR and R-Scuti. I will develop this thematic this afternoon. So I will go to the next program. Yes, the field of exoplanets. So in observatory, we developed this thematic and until 2010, and we have our first transit in 2010, and the first PhD graduate in 2015. And after, we have developed with the Belgian University of Liège a program TRAPPIST. You have to know that TRAPPIST have the same one in Chile. So we have two TRAPPIST, north in Morocco and the south in Chile. So it's the same program that observe and develop transit exoplanet. So you can see here the telescope, 60 centimeter. It's a robotic telescope, and is in operation in Chile since 2010. So scientific program of this program of TRAPPIST is exoplanet and comets, in mainly exoplanet. So there is the one in Oakhamden, the same like in Chile. This program is so famous by discover 7 temporary terrestrial planets in 2017 with NASA, and they did a super publication in Nature, which by Michael Gillon, a Belgian colleague. So after there's a PhD Moroccan, which valid this work. This demonstrate the high potential of TRAPPIST North for high precision photometry of exoplanet. Barkawi now is working with the Belgian team in Canary. Is a student of Kadayad, of our university. These are a famous discovery with NASA, with the 7 Earths, and another publication in 2021 of TRAPPIST. So now we go to another thematic, says toward the space, is another program, optical wide field patrol, which called OWL, with Korea Astronomy and Space Science Institute. It's installed at the Camden Observatory at January 2015. There is the telescope is about 60 centimeter, and you can see here the dome of Korean, which is named KAZI, and this program follow astronomy of bright near Earth object, observation of small body, and observation of bright variable star with imported determinate period, emission line. So KAZI may exchange may exchange personnel, scientists, engineers, students to participate in this collaboration, and they may collaborate on development and training of exchange program for staff and our students. So there is a publication for this program, the one in 2015, about from asteroid to space, which this program has referenced the already existing infrastructure at the Camden Observatory for detection and monitoring the near Earth object. So another in the perspective, we have a new agreement with ASC, with Russia private sector in 2022 to detect space debris and satellite tracking. And agreement, and recently we have an agreement with the space-able private sector to locate for location of the telescope. So we have mini dome will be added to the other domes. So let me finish by this project. You know that observatory of Moukemden is near of Marrakesh. So when Marrakesh, a great city, grow, have the risk of pollution light. So we decided to create a dark sky reserve around this our site in Moukemden, with a radius about 80 kilometers. So now we have a foundation of a dark sky, and we work to execute this program and make this area dark sky. So we have organized an international interdisciplinary workshop before COVID in 2018. So we have many thematic fauna and flora about around the pollution light, like fauna and flora, astronomy, health, social science, and laws and regulation, field study, modeling, clean lighting, and also tourism, to make the village around the Moukemden Observatory open to the tourist astronomy. So, in conclusion, I think I have respected the time. Though we conclude that thanks to the site testing and the scientific result, we have generated activities around Moukemden Observatory since 1980. And thanks also to good science and recent discovery, we have interested many international scientific institutes, and they lead a program in Moukemden. We have taken advantage to develop research training in our small group and continue now to grow up. Such Morocco now hold a prominent place in North Africa and Middle East in terms of publication related to astronomy and astrophysics. Thanks to Moukemden Observatory success story, we can state that we will have like to have other small ground observatory, and for the site located especially in the third world region in Africa. Beside undeniable scientific importance of early and complement of big terrestrial and space projects, we have to encourage the training, research, and connection between researchers. I think I finished at time. Thank you very much.
Thanks very much, Abdul-Majid. Yeah, you certainly kept to time. You actually had more time available to you, but that's more time for questions and comments. So let's start off with the audience here. Has anyone got some questions for Abdul-Majid? I just want to make a comment. With your experience in site testing, this could be very valuable for some of the initiatives within AfAS, in particular in Ethiopia and Kenya, where I'm aware of plans and more than plans, actually, some infrastructure development to do this. So I would just encourage, collaboration and sharing of your expertise in this, because I think that would be quite a nice thing that could come out of your work in the site testing there.
Sure. Yes, I just want to. Yes, excuse me. Yeah, in this side, I just want to tell about the experience with the Egyptian colleague. So the Moroccan colleague works with the colleague Egyptian to have a new site city in Egypt. So yeah. I think with the other colleague in Africa, that's welcome.
Great, yes. Thanks very much. Lero, you had a question?
Thank you, and thanks for a great talk. So I think currently, as well as hardware on the ground, such as telescopes, it's really good to develop a good computing background so that one also exploits data coming in from the other telescopes around the world that are making that more and more available. And quite often the computing becomes a hurdle. I'm wondering if you are also developing some computing infrastructure for your development.
We have our own. You want to talk about software to monitoring the telescope?
No, high computing. No, more like a high computing power and high computing storage. So big computing infrastructure to be able to handle big data from other places.
No. Yeah. No, we have an experience, for example, for the program of spectroscopy. So since 2050, we lead many campaigns. So for usually about 6 or 7 months. So we have a lot of data. And we work with WHP in France, and really we use some free soft to manage this data, but we don't have a computer managing for. So we have a project to develop. I think with Egyptian and our colleague in France, a soft like that because we have much data in big data in spectroscopy and photometry, and sure that we have and now I ask if there are some colleague African to help us to do that, and you are welcome. Thank you
very much. I think we have time for one quick question from, what's that? Yeah, no, I mean from the
Mariana.
audience here. So Mariana had her hand up. Very quick, Mariana, please.
Okay, thank you. The first is the average seeing that I don't remember what is the one that you have, the site. And then the second, how much demanding is the time, that observational time that you have? So are you managing to fulfill with projects and observations all the observational nights that you have, or you do have some space along the year?
If we manage our time to observe, we have.
So what I mean is how demanding is are the telescopes? So are you managing like along the year? Are they filled with the project's observations, or you know, you?
I can respond with my program. We have a totality of time to observe in spectroscopy, and with the program we have I think about 30% to observe only for the student in observatory. But we have access to the all data of each program, and I think that with each program we have in collaboration and co-tutel a PhD student to analyze data which for each program.
And I think it was 1 arc second. Yeah. I think we should take some questions from our online. So, yeah.
I see that.
Yeah.
Khadija or Min. Okay.
Right.
As you like.
So, yeah, I'm just looking to see this one.
Hello?
This one?
No, this one.
No.
Khadija.
It's moving.
No.
Hajida here.
Yeah.
Yeah, right. Oh, okay. Sorry, I wasn't sure what I needed to do. Yeah. So, Kajito, if you want to ask your question, go ahead.
Okay, thank you. I understand that you've installed some radio dishes in Morocco. So would it be possible for you to elaborate a little bit on that? And if you started collecting some data from these radio dishes, and how big they are?
Data about which subject?
So I understand that there are some radio
okay.
dishes installed in Morocco, and if you can just elaborate a little bit on that.
Bonjour Khadija. So I will inform you, it's very, very elementary that we have beginning, I think, this year. So we have with the Atlas Golf a private particular which have this radio telescope, and this year we have I'm a student in Master of Astrophysics, which working in the data. So if you want, I can give you the contact, and I hope that he will tell you more of this field. But you have to know that's a new field, and I think that all collaboration will be good to develop this area. Thank you.
Thank you.
So one more question, and then I think we have to move on. So it's from Maron. Yeah.
Maron?
Yeah.
Yeah.
Go ahead.
Yes. Thank you very much for your nice presentations. So I just want to know more about the light pollution. We know Ethiopia. I'm from Ethiopia. So what are the basic infrastructure that we have to do, because now we are doing the infrastructures? So even about the exposure time. So I am a little bit far away from these topics, but I want to know more to how can we have a good seeing, and also how can we make the exposure time to be good for us in our observation. So because we are doing on this infrastructures and also on. So can you give a suggestion for us for new comer observatories for such as in Ethiopia, such as Ethiopian Space Science Technology Institutions? And thank you.
I understand that you have site testing.
Look, I think this is quite a general question that could take half an hour to answer, to be honest. How to ascertain things like exposure times and when to do observations suited to the seeing. Those are the sort of questions you're asking. Is that right? Maron, is that correct?
Yes, I think that's correct.
Yeah, so I think, look, it really, we really are pressed for time. And as I say, this is quite a detailed question. So I think take this offline and you can ask the question generally, actually, to both Abdul Majid and others. So I think let's wrap up the questions for now, because we need to move on to the next talk. So Abdul Majid, thank you very much.
Thank you very much. Thank you.
The next speaker is Leratodi Liu from the University of Western Cape. He's going to give an update on the African cosmology and astrophysics strategy. So I'll give you a 5-minute warning before the end of 20 minutes. Oh, you're there.
Yes. And I use this button here. Okay, this one, yeah? Okay. Yes, good morning, everybody. I'm Leratodi Liu. Actually, I'm going to take half a minute and try and answer Miron's question, just to be kind. I think she's saying, if you have a lot of light pollution, how do you do good astronomical observation? And essentially, I mean, one trick is to understand what your light pollution the light pollution that's really bothering you for what you, and try and go and see how you can go around that. So for example, some people will do spectroscopy, and then in the city, they will figure out which lines are not from the, the urban lights. So if there's some specific line, for example, that's not so bright from the, the general line, lights that are around you, you can just pick that one and try and see what observations you can do for that. Or if the seeing is really crazy, try and think about observations that are not dependent on seeing. So I now talk about the African strategy for fundamental and applied physics. And indeed, I was answering because part of the reason of the strategy is to try and see what other people are doing and how to coordinate, to understand the expertise that's around the continent, and see how to grow from that. So it was probably good that I started by answering this question. I'm specifically talking about the astrophysics and cosmology part of this strategy. It's a very wide strategy that includes fundamental physics and applied. The astrophysics part is led by the 5 people listed there, with Mariana playing a very leading role, and she's our leader and instigator. So I'm trying to move this with the arrow and it's not happening. How do I move it? Okay, with the arrow. So for my talk, I'm going to spend half of it talking about just this particular working group, the astrophysics and cosmology one. And because it's most relevant to people here. And then I'll talk about it, the African strategy in more general. So give you the broader context later. And I've decided to start just talking about the working group part, because that's the takeaway that I would like you to go with. So the people who are leading this working group, those are the pictures and where they come from. And please talk to them. That's a little bit more about the people leading and the subgroups that we've created within this big astrophysics and cosmology one. And these people are just there as leaders of these subgroups. For example, I've taken up the leadership on the transient and pulsars and high energy. These are not my areas, but they are just subgroups that didn't have particular expertise within our leadership. So we'll actually look to having people leading those particular subgroup, and I'll just be the one doing the corralling to make sure that the inputs are coming in from them. So we have solar physics under Priscilla, stellar astronomy, and planetary science, and then those other groups that are listed there on the slide. And of course, because this is a really big group of sciences that we are trying to tackle here, there are some overlaps, and we are also, so this particular group is in touch with the other working groups, and as well as corralling input, we'll also be trying to deal with where these overlaps are and managing that. Something, for example, that you might think is missing here is outreach in astronomy. And that's because outreach for this huge strategy has its own working group. So outreach in astronomy is dealt within that particular working group. And in this case, for example, Sivuyile, who also does a lot of outreach, is leading, in this particular working group, he's leading cultural astronomy, but he would be interested, for example, also talking to the working group on astrophysics. So what we would like everyone to do is look for their subgroup of interest, reach out to those people, and communicate through them. And do not worry if there's an overlap. You can join more than one, and if there's an overlap you don't see here, it's probably in another working group. So the strategy itself, it's aimed at strengthening innovation, education, and research across the continent, coordinating that, and so that there is like this one place all for both coordinating current activity, but also having something to say about where African physics is going in the future. So for our particular working group, we send information through particular networks such as AfAS, the African mailing list, Women in Astronomy. I think we may have missed the SA Astronomy group, and maybe we need to get to them as well. Up to now, we've had 110 people respond from 21 African countries, also with some in Europe, South America, and Asia. So this includes people from outside Africa who have an interest in these topics that we mentioned. In terms of the particular numbers and the groupings of the responses we have for the moment, we have those particular percentages for the subgroups that I listed here. So would definitely, this, I think it's only half of the story, and we would like to see more, but that's where we are at the moment. So at the moment, we've seen the responses. The strategy works by this particular method of first sending in letters of interest, and then later on, developing those letters of interest in what will be called white papers. These white papers are actually, the idea is that they would be published then in this big publication, and might actually go out for print, refereed journal and everything. So you should actually get a publication out of this as well. And as I say, also really this important reference that we all can use then for if you want to touch base about any physics happening in Africa. At the moment, the astrophysics is 20% of the letters of interest received by the entire strategy for so far. So we are doing well, but I think we can do better because astrophysics is really, really big in its activities in Africa right now, as such as this meeting here demonstrates. For example, I shared some news about this meeting to the organizers of the strategy, and they are just in envy of how far astrophysics already is. And I think we can leverage this to see an even bigger impact coming in from astrophysics, or impact on science across Africa. So the organizers of the big strategy also like me to share this fact that we originally have this idea that you start with a letter of interest and then grow to these white papers. But at the moment, we are actually not getting enough letters of interest, partly because there are probably some of you who haven't responded yet. So we are a little bit more flexible now about these letters of interest. For example, they could include a one-liner now with this flexibility, just saying that we had this conference, this is the link to the conference, and we'll write more about it later. So we are a little bit flexible now about what they can be. So don't be shy to actually put one, you could just do one and a few lines, to say what you are interested in. And these letters of interest can also come from just your individual interest as a scientist and what you'd like to see going forward. But they also could come from your working group, your research group, your department, your country, or they can be from an individual to a group as big as AfAS. So they can take many different shapes. So please contribute in all these possible ways. So just to give you the context part, and the context in this case, I am taking slides provided by Professor Farida Fassi, who is one of the co-founders of the strategy. She presented this last week at a meeting, an African physics meeting that was happening. And she notes that the strategy comes from this bigger context of challenges faced by Africa, and she's listed them there. She also notes that the strategy comes in with an outlook of the challenges for Africa in the future. Particularly, she notes here that currently, youth are like a really huge percentage of population in Africa, but it is actually projected that in 50 years or in 1950 and in 2100, things will actually change so that they become a bigger part. So it's really, really important that we give them a good grounding, youth, if we want Africa to succeed. So the strategy is really with this bigger outlook for Africa, and we really, please think about participating with that light. So she knows, what are the challenges and where are we heading. So the strategy is actually looking to make impact across the African continent. And she notes that the scientific community has a role to play in the sustainability of Africa. She also reminds us that physics has always had this big role in the progress of humanity, and how if Africa is to move forward and and progress with the rest of humanity, we need to be doing this. She also notes that there are strategies across other places in the world, across other continents, and that we don't have one in Africa, and so we need to do that. So this idea of doing these strategies has been happening elsewhere. In the US, it happens in astrophysics, it happens in particle physics, so too in Europe. And so we are taking a lead from that. But she also notes that we actually have a lot of good things already happening here in Africa. As you can see, she lists some of the astronomical activities happening, some of the activities in bioscience, some of the activities in nuclear science, and also across different regions. So we do have challenges, but we also have a lot of strength, as shown here again with SKA, other projects across happening across Africa. So she's not like talking, it's not proposed with just a begging cup, but we are trying to work on our strength to move forward. Also noting some of the other challenges, such as underfunding of R&D, research and development in Africa, and then just Africa not having enough skilled people, not enough PhDs, as a UN study has shown. So part of what we will need to do is also, address things like how we improve funding, how we improve skilled development as we, make this impact. And then the objectives of the strategy worldwide are listed here. The strategy has a website, so you just have to Google, this strategy, and you will find it. So, like as noted in my title, you'll find it. The 5 co-founders of the strategy are shown in this particular page: Keteve, Simon, Farida, Shabana, and Farouz. So I am just an advocate of the astrophysics one. So the founders also note they are aware of other strategies that are, let's say, find their roots in government and other organization. But this particular strategy is not top down, it's supposed to be grassroots up. So notice that we are aware of these other big African strategies coming from the government, but we are taking this other approach. The organization of the big strategy committees, has this big laid out structure there with some steering committee, with international advisory committee, with ethics. And so that's the the broad organogram shown there for you. And so there's been a lot of thinking behind it. And all this information, by the way, is at the website of the strategy. So this is the structure of how it's moved forward, as I've been describing right now. And here we're just showing you all that in terms of this diagram. And on this slide, I'll just go to the point that we are sort of at the edge now, taking letters of interest that will lead to these white papers, and those will lead to a summary and final report. So that's where we are going, but a lot of work has happened already. It's been 2 years in the making up to this point. And if you just like to know what is behind, for example, these are the list of people in the advisory committee. They include people from Africa, but also from across the continent. For example, we have Prof. Velekasi, who's the Vice Chancellor of Wits University. We have Dr. Malik Maza, Itamba Lab, originally from North Africa. We have, Professor Gates, who's, I think, president of the American Physical Society now, and he's at Brown. We have Rob Adam, who's the director of the SKA. So this, the organizers have made a big effort to reach out to all these, the broad expertise around the world, so that this strategy is really well informed and well grounded. There's also been a sponsorship from different organizations, and they are listed here, including the Department of Science and Technology here, but also international organizations as listed there. So this particular slide is showing you some of the working groups involved. So you can see the physics working groups there, and Astrophysics and Cosmology is just one of the 14. So all the different areas of physics are covered, or there's been an attempt to do that. I mentioned that engagement is a separate working group, and you can see that under engagement, there's even more working groups, such as ethics in science and physical science, community engagement, observers, and also Young Physicist Forum. By the way, the Young Physicist Forum has been really, really active. They've already held, 3 or 4 meetings that I've joined some of them. So you can join any of these committees as well if you think you would like to see what's going on there, maybe have a say. One of my former PhD students is actually leading that. So as a supporter of him and a supporter of young people, I'm active in that. So you can get involved through all these regions. And as you notice, there are also room here for involvement by administrators of science, physics. So you do not have to be a scientist to be involved in this. There's room for all these, for different expertise and participation in science. We go into things like, we are very specific into a code of conduct of how things happen. This is all in the webpage. I'm just showing that. And then just an update, I already mentioned of where we are. We are in the stage 4 of these white papers and now moving ahead. Of letters of interest moving to white papers. So I mentioned how you can get involved with these letters of interest with an example of what I'm doing here, talking to groups that you work with and telling them about this, all these different ways. And this is my last slide, just about the summary of it all, which is that this big organizing committee for the strategy has formed strategy in fundamental and applied physics, of which astrophysics and cosmology is one working group. And it's done to encourage and strengthen science education and capacity in Africa. So we look to your involvement. Thank you, and thanks, Dave.
Thanks very much, Leratodi. Can I just ask for some clarification on the letters of intent? You were talking about letters of intent specific to astrophysics at the first part of your talk. These letters of intent for the strategy are other letters of intent. Is that correct? Or is it the same thing?
Same thing.
Okay. Questions from the audience? Yeah.
Thank you for the presentation, a good motivation. I observed that the code doing nothing is going backward. I repeat, it is okay. It is too huge. You started with African strategy for fundamental and applied physics. And then you focused to astrophysics and cosmology. Again, within astrophysics and cosmology, there are also broad things which are also not focused. But you have also commented that the possibility of focusing through participation of ourselves, that is good. Still, I do have much confusions. Astrophysics, cosmology itself is also astrophysics. And also when you list stellar, in some stellar, still we have high energy astrophysics still. So there are some and many interfaces and so on, so on. I think you have to work on this one, or we have to work on this one based on the expertise. This is my comment, and also my concern is, for example, in my case, it is very difficult to put myself in some of these parts. Why? Because I'm an theoretical astrophysicist. I work around active galactic nuclei in gravitation, in cosmology, so on, so on. So it is difficult to place myself in one of them. Thank you very much.
Do you want to make a response, Lera?
Yes, so it is a very ambitious strategy, no doubt, and I'm glad you are picking that up. So we are noting that you're saying theoretical cosmology and maybe gravitation isn't properly included. And so if we had this oversight, then we are happy to adapt. It is a process, in development. So if it's not covered, we can include this. We tried to make the working groups to be within astrophysics, to be around science. There are all these different ways that one can make it. For example, we didn't, for example, do the radio and optical astronomy division. We didn't divide by wavelength, for example. So we are quite mindful that you can organize this thing differently. And we are also happy to try and to improve if, as suggested, yeah.
Sorry, can I just add one thing?
Quickly, yeah.
Yes, quickly. Yeah, I mean, just one important point is that all the structure that Lero presented, I mean, this strategy is in a constant evolution and constant change, depending on, what the trend will be, no? So these subgroups that have been defined are very, very broad. So you can actually participate in several of them, related with cosmology, with stellar, with extragalactic, and so on. The thing is that, and also depending on the feedback that we get from the community, it will be in the constant change. If we see that we need a specific white paper to specific sub area, because there is a lot of interest, a lot of vision, a lot of need from the community to develop something in particular for the future, then nobody stops us to extend the work, no? So the important point that I would like to raise is that it's a constant evolution, and what we want is really to involve as many people as possible in all this process, going from the letters of interest, all the discussions that we will start now under the subgroups, and then development of the white papers later on. And we don't want that the white papers have only few authors. We want that the white papers have as many authors as possible. So basically all the people that will take participation, not maybe along the whole journey, but in some parts of the journey. Either you send your letter of interest or participate in any other process, no? So that when these white papers come to the decision makers, governments, and so on, later on, that this is really the reflection of what we want to see, where we want to see the astrophysics cosmology in the future, no?
Thanks, Mayana. We have online questions. So first one from Ndongmo, if you'd like to ask your question. You're unmuted, so you should be able to speak. Well, maybe we move on to Takalani, because I don't see any response from Ndongmo. Takalani, do you want to ask your question?
Yes. Thank you, and also for the presentation. Yeah, okay, just one or two questions here quickly. First, I saw the Department of Science and Technology there. I don't know if that is referring to us, because we are the Department of Science and Innovation. So if that is the case, I think Lerotori will be forgiven. But if he repeats it again next time, it will be a jail sentence. Then the other one is on this, astronomy or astrophysics and cosmology strategy. Are you going to, is AfAS going to run with that eventually in terms of running with that strategy? So the broader question I'm asking here is because you've got institutions that are already there that touches a number of those working groups. In other words, the institutions that are already doing work in those topics. Is the idea going to be to use those institutions to run with that particular aspect of the strategy or not? So thank you.
You want to answer that quickly? But very quickly, because we're really over time.
Okay, so at this stage, we are looking for participation and not excluding. So if indeed AfAS wants to have a big footprint on this, AfAS can. And so we are looking for more participation rather than less. And we would be grateful if AfAS would come in and say, we want to be part of this in a major way. And apologies, it is Department of Science and Innovation. So, I mean, that could be a letter of intent, Takalani, to try and, say how this came about, that you think actually it's good now to refer to yourself as Department of Innovation rather than Technology, and what this means for Africa going forward.
Can I just make one clarification?
Sorry, we just don't have any more time, Mayana. So I'm sorry, we have to move on. We can't take any more questions. Thank you very much, Lara Cody. So the next talk is from Carolina Odman. Is this a Zoom talk? Yeah, yeah. Oh no, she's here. I thought you were physically. So Carolina's going to talk on translating science people first.
I was thinking you were going to give the talk there for a second. Okay, good morning, everyone. Thank you to the organizers of this meeting for the invitation to speak about this project. I could honestly talk about it for hours, but I just have 20 minutes. So I decided to focus on some of the key things that we've been learning while trying to translate astronomy and materials in astronomy into African languages. But really, it really comes down to this. People first is the most important. So to set the context a little bit, I have a few quotes for you. This first one from Martin Luther King Jr., who says that our scientific power has outrun our spiritual power. We have guided missiles and misguided men. I think this is a very profound statement that speaks not just to maybe the lack of awareness of the role of science in our lives, but also the mistrust in science that we find in this world, and the very, very real consequences that this mistrust has for our everyday lives. Whether it is believing public health recommendations, or whether it is to do with the benefits of science and for society in general. So I think this is one element of the context, is that science has really an image problem and a trust problem. The second quote, second element of this context is of this very well-known quote from Nelson Mandela that says, if you talk to a man in a language he understands, that goes to his head. But if you talk to him in his own language, that goes to his heart. And I think this is also very important when it comes to not just science, but how we understand and how we learn science. If we learn science in our own languages, then we are better able to understand it, and we are better able to share it as well. And the final quote I'd like to share with you is from Christine Kunta, a South African lawyer and writer and activist, who said in a newspaper in 2002 that underqualified teachers, poor infrastructure, and impoverished social conditions, all of which are inherited, are some important reasons for the poor performance of especially African students, this being in the South African context. But a far bigger problem for African students is the medium of instruction in maths and science. And this is, in the South African context, you should know that children learn maths and science in English or Afrikaans from grade 4 onwards. And it's really from grade 1, 2, 3, the medium of instruction is the children's home language or mother tongue. And then suddenly after grade 4 upwards, maths and science is mainly in English and sometimes in Afrikaans. So it's really, we're facing a problem where most children in South Africa, and I think this is an issue that can be generalized to the broader context of the continent, is that maths and science isn't taught or learned in people's first language. The challenge for children to learn is big, but equally for teachers to try to teach a topic in not their first language is also equally challenging. So to help with this issue, there is something called, so obviously this issue is not new, it's been studied a lot from people in linguistics and in education. And there is something called mother tongue-based multilingual education, and it's been very well developed and very well studied. But what this is it's an education that begins in the language that the learner speaks most fluently, and then gradually introduces other languages, right? So imagine in the South African context, for example, from grade 4, you start to introduce math and science in the languages, in the learner's first language, gradually until, say, grade 9, ideally, because in South Africa, that's where learners choose between pure mathematics and mathematics literacy, which is a field that can appear practical and attractive because it has things like, you know, budgeting and home economics and things like that in it, but in fact does a disservice to learners who might wish to study math and science, because if they choose maths lit in grade 9 and they finish their matric, so the end of their schooling with maths lit, they are not eligible to sign up at university to study math and science. They need pure mathematics, which sounds much more abstract in grade 9 where they're 15 and they decide to go, you know, where to go. So this is really an issue. But the thing is, this mother tongue-based multilingual education is really one of the keys to realizing the Sustainable Development Goal number 4, which is quality education, ensure inclusive and equitable quality education and promote lifelong learning opportunities for all. And you'll see on this image, there's a bit of context here about how the reality of a multilingual world is really the reality for most people. Turns out that about 2.3 billion people learn in a language that isn't their first. So this is really beyond South Africa, beyond Africa. This is really a global problem. And most of us live in multilingual environments. So what we've done is we started a collaboration to try to translate astronomy resources into African languages, and this collaboration in particular to translate into isiXhosa. So Dr. Sebolelo Mokapela, she's the head of department in the Department of African Language Studies at UWC. Dr. Honji Konana, she's an education specialist in the Faculty of Science, and then yours truly. And then we have what we've done. We've enrolled 2 master's students. So they're not master's students anymore, but when they were doing their masters, Mr. Sinathemba Nobom, he's a master's student in linguistics, he's now a lecturer. And Mr. Shaka Mofokeng was a master's student in astronomy. He now works here, I believe, as a software developer. They came together to try to translate this astronomy resource, which was quite simple. It was started with a resource with information about careers in astronomy. And the reason why we started with that is because, well, there was a need for such resources, and also we need to give young people awareness of the career opportunities that science and astronomy brings, but also we need to give them the means to discuss such an interest and such a passion with their families, so that if that's what they want to study, so that it makes sense to everyone. And we realized that, you know, there was a lot of translation work and even new language that needed to be included and developed to be able to translate these resources. And so a few of the important lessons that we've learned are that, well, firstly, indigenous knowledge plays a very important role in this. Because if we want a scientific language to be truly indigenous and come organically out of a language, we need to acknowledge all the knowledge that is there in the culture and in the language already. So beyond, so for example, indigenous knowledge plays a very important role in fields like pharmacology, where people have knowledge about medicinal plants and their applications for various medical ailments. But in astronomy, indigenous knowledge has been described a little bit more in sort of anecdotal terms and historic terms and cultural terms. But what we've learned is that we would rather argue for that indigenous knowledge to be included in the modern scientific language, in the sense that, for example, if there is a term, we have objects in the sky, we have open clusters that we can see with the naked eye, we have galaxies we can see with the naked eye, and the words and the names for those objects in the sky should be the name of those objects within the science, because then they are connected with something that one sees, something that one is aware of. It helps stimulate the scientific instinct as well, because there's a way to relate to something that's known and something that is familiar and something that is one's own, as opposed to something that comes from a foreign language, different concept, and that is imposed with as many other things of often a colonial nature have been imposed upon people. So indigenous knowledge is really critical. A second thing that we've learned is for the adoption of such, say, new language and new words in science in African languages, there needs to be a legitimacy. And for it to be legitimate, it is not something that we can just come up with. It has to be issued from a conversation between the communities who will use that language and who are trying to teach science, and the astronomers or the scientists who have the domain knowledge. And only through an equal dialogue where peers with knowledge of either language or community or the culture and peers with the knowledge of science are on an equal footing. Only then can new expressions of modern science be adopted in African languages. And the third lesson is that language is more than, say, vocabulary. It is an entire thinking framework. And the way, this is particularly the case in science. Western modern science thinking is it's very categorical. We label things, we categorize them, we put words in dictionaries, we assume that a word has a meaning or several meanings, but it is the unit of meaning is the word. And that's quite a Western way of thinking. In fact, there are lots of languages where meaning doesn't arise from the application of one word in a context, but from a string of words. And there are lots of languages that are sort of very descriptive in nature, where a whole sentence is the meaning rather than just a word. So we have to think beyond those traditional Western structures of language to be able to open the door to a truly legitimate and indigenous way of speaking science in African languages. And another lesson learned is that this facilitates sense making. When learners are learning math and science, which can be quite abstract in their mother tongue, when it is easier for them to make sense of what they learn. It is therefore easier also for them to communicate it because they are comfortable in that language. And multilingual, mother tongue-based multilingual education is well known to also contribute to the creativity of children and people. And so I think we all agree that being able to make sense of things, be able to communicate things, and be able to think creatively are three very fundamental characteristics to science. But of course, this is just a journey, and we have many more lessons to be learned. And so one of the things that we haven't yet been able to do is really to test our translated resources within a community and get the full feedback. We've had the dialogue, but in practice, we haven't worked with teachers in training or with schools yet. And so the reception of our resources among teachers is something where we expect to learn a great deal from this effort. Similarly, the reception of our resources among learners will also be very, very interesting to see how they think around these new concepts when they are able to think in those in their home language. And I think it will also be very interesting to see how the community, how families, how parents maybe are able to talk about science in their families. And this contributes to the third point that I've put here of lots of things that we still need to learn in terms of the spread of scientific ideas. It's been shown in mother tongue-based multilingual education that new ideas, if expressed in the mother tongue, spread across the communities because there are ways to talk about those ideas. And so obviously we are very excited to see what happens now if we talk about astronomy. And then obviously the door is open. I'm sure there are many more things that we will learn from this experience that we haven't even thought yet. It's already been an incredible journey of discovery. So we're very excited to see what we learn. So next, I would like to share with you just a few resources, because obviously we're not the only ones doing this, right? In fact, the inspiration for this project started with this article from science journalist Sibusiso Biela, who wrote Decolonizing Science Writing in South Africa, where he wrote about writing paleontology article in isiZulu, and how he also had to come up with words and took the opportunity to come up with words that are more reflective of the actual meaning, scientific meaning, than the words from English that were established when the knowledge wasn't quite as it is now, and they reflect the state of knowledge in the past. So this is a very big source of inspiration. But then the IAU also has an astronomy translation network. And while I mentioned earlier that language is a framework for thinking, there are still languages, obviously, who are able to assign a word to a meaning and so on. So this is a very laudable effort from the IAU as well. Now, the FET global initiatives, I guess most of you will be familiar with the FET. These are physics education and training. These are physics experiment simulation that happen online, and they are a great aid for teaching physics. So these are sort of online simulations of physics experiment that learners can interact with, whether it's a pendulum or whatever. All the, a lot of physics. This started with physics, but this includes now chemistry and biology and earth science, I think. And they have this global initiative where they it's a drive for translation of those simulations. And they've in fact recently received a grant from the MasterCard Foundation to translate all the simulations and the teachers' resources and so on into 10 African languages. So this is also very exciting. Then I'd like to mention our colleagues at the University of Zululand Science Center, who for the last 5 years or so have been giving science shows in isiZulu, and have also looked at how learners' understanding and enthusiasm and learning progresses when the shows are actually given in their mother tongue. And I'd like to also mention my newest colleagues in this initiative, the UWC Center for Multilingualism and Diversities Research, who are working with teachers in training and have a very interesting approach where they develop bilingual resources, so scientific lesson resources that are written in both English and Xhosa together to see how that works in the schools and with teachers. And so this is a very interesting approach, and I'm very excited to be able to collaborate with them also with our astronomy resources. And I think this is really where we are at. It's a very exciting project. Obviously, we look forward to hearing back from all of you about it. And we really think that when everyone can talk science in their mother tongue and integrate science in their thinking, then only will science truly become a public good. Thank you so much.
Thanks very much, Carolina. That's very interesting indeed. Any questions? Yeah. Majid.
Thank you, Professor. So my question, I think we have same thing in Morocco. We have a large community Berber. So we are in faculty university, we teaching in French. So students are Berber and speak Arabic and learn in French. So they think in Berber, speaking Arabic and learning French. I think it was disadvantage to. So my question is, what do you think? You know that language and culture are close connection. So how to go past some tradition culture to learn science in general and particularly in astronomy? Thank you.
Thank you. Excuse me. Yeah, that's a very, very good question. And it's what an interesting context, thinking in Berber, speaking in Arabic and learning in French. It's very interesting indeed. I think there's a shift now, I mean, at least in the education, that students who speak more than one language really have an advantage because they have a richness of thinking because they know more than one language. Now, the work that we have to do is to be able to enable learners and students to make the most of that advantage and create a teaching environment where it's okay to think in Berber and speak in Arabic and maybe speak a bit in Berber and think a bit in Arabic and mix a bit of French, and so that all three languages become a legitimate medium for thinking about science, because then the whole the richness of the creativity that comes from speaking many languages, the ability to think in different metaphors from different languages, different expressions. We all have expressions that we cannot translate, that are just perfect in one language that can't be expressed in another language. Well, if we enable science to be spoken in all these languages, that would be great. But I think in terms of the education environment, we need to enable that. But there's also, I acknowledge, there's a pressure to keep the education, at least at tertiary level, in the language of the market, where jobs are found and so on. So I guess in Morocco, that would be French. Here in South Africa, that would be English, because if you come out with a degree in science and you don't speak English, it would be very difficult for you to get a job, for example. So it's, I mean, there's pushes and tensions. That's why I like the mother tongue-based multilingual education model, because it introduces the language of the market sort of gradually, the sort of lingua franca gradually over the period of schooling. And I think that's a very interesting aspect of that model. Thank you.
James, you have a question?
Yes, I'll start with a comment. Thank you very much, Carolina, for the talk. I can truly identify with the content of this talk because I grew up with one Nigerian language, English language, bachelor and master's degree in English, and then PhD in Japanese and English, where I have to think about a problem in English and translate it in my head and talk to people in Japanese. But I've seen the same problem with the Japanese. I do have a current Japanese postdoc who still writes his journal articles in Japanese and then afterward translate it into English. And I asked him why. He said, I can't get a flow of my ideas if I write in English. So I understand the need for this to be done, but there are lots of challenges which I would like to know what your thoughts are on how those could be addressed. One of the challenges is most of these languages are grossly incomplete. You don't have words for example, thermodynamics in Isitosa. In Igbo language, you can't translate that. Some languages, temperature meaning could give you something different if you really think about the true meaning. So the incompleteness of most of these languages is one of the huge challenge. The second one, which is a very big one, is the timeline to get people to start using this language. Remember, you have to cross the first hurdle of making the language fairly complete. It mustn't be fully complete. Japanese is not complete. They still use English word, write it in katakana and use it as it is, but change the pronunciation, and then they use it that way. How long do you think it would take? Let's take the South African case as an example. How long do you think it would take the 10, 11 languages in South Africa to be able to get to 70% completeness so that you can get all the words when you translate and be able to teach the people? Because if you get new words into a language, you need to teach everyone that new word. Otherwise, it becomes still foreign to them.
Yeah.
So what do you think about the timelines? Are we thinking about centuries? in case I would like
How
to.
long is a piece of string? Yeah. No, thank you so much for your comments. They're very pertinent. The completeness of the language is one of the things we have to be very careful about, is one of the reasons why we're working with linguists. So I mentioned indigenous knowledge. Indigenous knowledge is also not widespread. So one of the things Mr. Nobom said was that he wanted to go and speak with the elders of his community and describe the astronomy that he had learned from his colleague astronomer and ask them about it and see how they talk about it and then bring that back in, because a lot of indigenous knowledge sits with the elders and isn't necessary. You know, we also lose it as we lose generations, right? And it's very important. But there's quite a few things I can show you another talk that I've given on this, where I give a bit more detail on this. But it really relies. We really try to rely on the language. So rely on the structure of the language, rely on the things that exist in the language. So I'll give you just one example. How do you say astronomer if there's no word of astronomer for astronomer? What we found is that, well, everybody knows what a weather forecaster is. And if you stretch that word to mean scientist of the sky, that can be an astronomer. So you can say sort of the equivalent of weather forecaster, but for the stars and beyond, right? And then you can build something that means astronomer that is accurate. A lot of the English words, if they're co-opted straight, carry their history. So if you think of astronomer, the origin in Greek means arranger of planets or arranger of stars, which is obviously not what we do. So it's also an opportunity to make the etymology of the word reflect the knowledge and the state of things today. So there's a lot of things that we can do. And then in terms of timeline, I don't think there's an answer to that question, because language always evolves. And language evolves based on the need for people to talk about things, right? And so if we can convey the message that science is important in people's lives, then adoption of conversations around science will happen. And if we can provide then, you know, ways of talking about it through schools and things like that, then I think, you know, that's the discussion of adoption. But I don't think I can say like in 6 months' time we'll be 70% ready and everybody will speak like that. I don't think that's possible. But it's you know, we dream big. We try to be ambitious. Thank you for that.
I think we've got a couple of questions on Zoom here.
Oh, yes.
Can you see? I can't quite.
Let's see. Oh, light pollution. No, sorry, is that? Oh, Katrine. Okay, yes. There is so much cultural astronomy and indigenous knowledge that can be learned about in this process. Is your team planning to collect this as well? Oh, yeah, this is a very good question. I don't think we plan to collect any indigenous knowledge, because the indigenous knowledge belongs to the communities and belongs to the elders who are the custodians of it. If they are willing to share it in a way that is, you know, that lets it be collected, then, you know, we'd be very glad, obviously, to have records of it. But I think even the way we record it, whether it's in writing or film or whatever, all those are new media, and they come from traditions of often oral traditions, right? So, or even kinesthetic traditions in the form of ceremonies and things like that. So we are very respectful and very mindful of the ownership of indigenous knowledge belonging to the communities.
We have one last question we can take. I'm not sure.
Yes.
Oh, yeah.
Sandile.
Yeah.
Good morning, Sandile.
Good morning, Prof. Thank you so much for the wonderful talk. I just actually want to commend you and your team, the work that you're doing. I can really relate so much, as we are science centers in the country trying to demystify science through demonstrations and articles and whatever that we do. And what we have noticed is that when you start, you know, engaging the audience with the, you know, indigenous language, you see the responses, you see the kind of engagement when you compare it, trying to engage them in a language that is not actually theirs and so on. So these, I wish it could spread over the country and see how best you can be able to get, even if it's not really what we call it the actual curriculum, but all the supplement resources that could help the learners in the classrooms, that could help even the public in understanding the basics of science, will really help a lot. And really thank you so much for this presentation.
Oh, thank you. Yeah, thank you so much. Just to reflect on your comment, I think the teachers are really, really key for this, because the teachers in the classroom, especially in the sort of primary, middle school level, they will teach a topic, but the way they will talk to the children will be probably in several languages. There'll be Xhosa to Xhosa kids, and there'll be English for the other kids and whatever. And so if the teachers are comfortable talking, blending the lines between the languages, I think that would be, their role is really critical in this. Yeah, and obviously the science communicators as well.
Thanks very much, Carolina. We have to move on.
Yeah.
It was a great talk. Thank you. So the last talk for the session, which I believe is over Zoom, you'll set that up, from Sonal Askatra on AstroStays, community-led astrotourism. Okay, so you have 20 minutes to talk and then 5 minutes for questions. Thanks.
Hi, everyone. Please let me know if my screen is visible, and then we can. Is my screen visible?
Yes, it's visible on Zoom at least.
All right. But, hi, everyone, and a very good afternoon from India. My name is Sonal Askatra, and I lead the AstroStays project. It's a community-led astrotourism initiative that aims at using astronomy and science-based tourism for people that are residing in remote and rural areas to create new channels of revenue generations and hopefully stimulate economies. So today I'm going to take you to 16,000 feet up in the Himalayas to show you how exactly we've implemented this project and what is the vision for way forward. Now, what is astrotourism and why bother about it anyway? So broadly speaking, astrotourism is a form of experiential tourism that generally encompasses traveling for astronomy-related experiences. Now, that can range anywhere from going for night sky gazing in dark, remote areas, or for more scientific experiences like planetariums or observatories, or even chasing celestial events like solar eclipses or meteor showers. Now, the pandemic has dominated our lives for what seems like the longest time now. And in all of the things that the pandemic has changed for us, it has definitely changed the way that we perceive travel or the way we want to travel. And most of the trends and patterns that have emerged in terms of the tourism industry, it just reflects that the tourists of tomorrow, they want to move away from the built-up hotspots to more open and spaces. Now, the question is that how can the communities that are residing in these remote areas benefit once the tourism industry really starts? Now, by the very nature of astrotourism, the best vantage points of experiencing astronomy-related experiences are in remote and rural areas. Now, because most of the astrotourism is centered either around scientific experiences or led usually by trained astronomers or amateur astronomers, the benefits that astrotourism can bring to these local communities that are residing in these remote areas have been very, very limited. And one of the reasons being that because they either do not have the skills to participate or go on that path, or they have primarily been just absent from the entire tourism value chain. back in 2019, we were supported by the Office of Astronomy for Development to start on this project of AstroStays, which was essentially to look at astrotourism through the lens of community experiences. This was astrotourism that was led completely by communities that merged not only Western science, but also merged their indigenous folklores as part of the dark sky experiences. A bit of context about our organization, Global Himalayan Expedition. We are a social enterprise, and we've been working in Ladakh for almost 10 years now, primarily to provide clean energy access to remote and rural areas. So far, we've electrified 151 villages and impacted 67,000 lives. And because most of our work involves communities and community-related development interventions, we've always tried to maintain a very holistic approach once we get into these areas. So the first point of intervention is generally solar electrification. And Ladakh is a very tourist-heavy economy. I mean, most of the Himalayas, they are generally frequented by people who love nature, who love to trek. So there are also homestays that are gradually coming up. So it begins with solar electrification, providing the infrastructure to support that kind of tourism. And this is the geography. So the Himalayas, as you know, is a very, very long chain that runs from Afghanistan in the west up till Bhutan. And we work in the Indian part of the Himalayas. And among the many, many assets that the Himalayas have, clear night skies is definitely one of the most important assets that it has, and obviously also the most untapped. Why untapped? Because there are so many locals that are residing in these areas, but because they do not really have that skill or the infrastructure on how to, conduct these astronomy related experiences, it has primarily, remain untapped. So this is our team. All of us are primarily engineers. None of us are astronomers, and that is why I think it also gave us a chance to look at, astronomy-based tourism from a very different lens. So how did we really start? I'll take you on a small case study of what it took for us to implement this entire project. How has it done so far, and what is it that we envisage going forward? So the thing was that, because astronomy related interventions was one of the first kinds of interventions that was being brought into this area, it was very important that the community had to be mobilized in a very correct and cautious manner, also managing their expectations. So our team made multiple rounds and did multiple rounds of discussions with the locals, because eventually the whole aim of this project was to create a community-led model. So it was very important to get the community buy-in. And because astronomy can be slightly overwhelming for people who are not, familiar with that field, or come from, an educational background where they think that, it might be too daunting for them. So it was also very important to kind of set the expectations and let them know that, when they do kind of embark on their journey, things will be demystified and they will be able to curate such kind of experiences. So the community mobilization part was something that, we spent a lot of effort on. And of course, there were lots of focus group discussions that happened not just with the community members, but also with different stakeholders, the local administration staff, the local team who actually, was running with the project on the ground, and also the ecosystem that had to be created. Because if you, even if you create that project, you have to ensure that there is an ecosystem that helps to sustain it. So there were a lot of focused group discussions and community mobilization. And then came the training part of it. We took a very long time to, figure out and customize our training resources for the community that we were working with. The thing is that we I think, just one second, yes. So we trained around 35 people from 15 remote villages of Ladakh. And we took, we had almost like 3 days of astronomy workshop. And most of the people that we were working with came from very, very diverse educational backgrounds. Some of them were just high school dropouts. Some of them probably had not even been to school. So for them, to talk to them in their language and to prepare them for the kind of experiences that they would be delivering to the travelers and tourists was one of the most challenging part of us. And the way that we overcame it, in a small way, was that we started with their own existing belief systems about how they perceived skies and how their ancestors perceived skies. I mean, Ladakh, because all of these community members and all of these people stay in really remote areas, they are still using skies for basic mapping like navigation or shepherding or farming, looking at the patterns of the sky. And from then actually connecting it to the Western science became a little easier. And we also started in a very phased manner, not to overwhelm them with too much information, just start with really basics of astronomy, a few planets and few constellations, and one Dobsonian telescope that you see in the picture in the right. And this is a picture of one of our team members of Astrostays using stellarium to map the skies. So the way it works is that at the beginning of every month, we provide sky maps to the team on the ground. So with that, they get a sense of, what is the forecast of the sky for that particular month, what can they expect to see. And once the tourists and travelers come over for these dark sky experiences, the expectations are managed very well. The thing is that I think most of our generation is, very accustomed to 70 mm of gravity and interstellar. So for them to manage their expectations and to tell them that this is what you're actually going to see with the telescope is also very important as part of the entire experience. So this is how our team kind of manages it. And this is a picture of one of the homestays. Now, if you probably recall the picture of the part where the community mobilization was being done, the Astrostays have been set up on the banks of a very famous lake called Pangong. It's something that we share with China. And this lake is very high on the bucket list of most of the travelers who come to Ladakh. But they're usually day trippers. So they land in Leh from whatever part of the world that they are flying in, and usually take 5 to 6 hours to come to this lake, take lots of pictures and go back. Now, because Astrostays had been set up and astronomy experiences obviously necessitate that people stay back and use some kind of accommodation at night. So what also happened was that in addition to training all these communities in astronomy and creating these astronomy related experiences, we also trained them on hospitality and how to set up homestays. So they were opening up their doors to the travelers for the first time ever. And there were two channels of revenue generation that started coming in. One from the accommodation that the travelers started using, and another from the stargazing sessions that the community was conducting. And these are pictures of some of the astronomy sessions happening in Man. And again, a picture of one of the astropreneurs. So we have a 5-member team back in Man. 4 of them are women and there's 1 male. And why the team has comprised mostly of women? Because of the fact that because Ladakh is so heavily tourism driven, most of the male members, they move into the nearby cities or the towns to act as porters or chefs, engaging themselves in some way, form, or shape in the in the tourism economy. And it's mostly the women who stay back and run these homestays. So there's always a question of, was it by design? It really wasn't by design that most of the team members are women, but it's just because they are the ones who stay back. They are the ones who are managing the chores and running homestays, and that is why we chose to train them on astronomy as well. The second part of it was, so the training is done, the mobilization is done, and a very major chunk was how to do the market linkage. I mean, you can create these really beautiful hotspots, but if people are not able to access it, the sustainability of it cannot be ensured. And the area that we were working with is a really, really remote area. So back in 2019, when we started, it did not even have Wi-Fi connectivity. So we kind of went through 2 channels of market linkage. One was the online, where we started putting these Astrostays on popular platforms like Booking.com and Airbnb. And then also offline, where we started printing these small pamphlets and brochures and putting them in the visitor information centers to tell tourists that there is something like an Astrostay where they can come and stay and experience dark skies. So this is one of the screen grabs that I took from the market linkage that we've done in Airbnb. And this has been the impact so far. So we started in 2019 and then COVID hit. So 2 years, it was absolutely lull. But last year, after India had its second wave, there was a decent surge in domestic tourism where people were flying in from different parts of India to come to Ladakh. One, because it's really open and remote and people wanted to experience it. So AstroStays, so it also provided us with a window of an opportunity to see if we could see the potential of AstroStays. And I'm very pleased to say that it actually was a breakthrough year of us. So combined both 2019 and 2021, we've engaged almost 2,300 travelers who have come not just for accommodations, but there are also people who have come only for stargazing sessions as well, and empowered 14 women, and 610 AstroStays room nights were booked so far. One of the major objectives of this entire project is that the revenue that gets generated not just stimulates the local economy, but it also contributes to some kind of development intervention back in the communities. In those 2 years when COVID hit and there was zero tourism, the money that was generated in 2019 from all of these AstroStays and the stargazing experiences, that money was repumped back into the communities to buy solar water heaters. I mean, because Ladakh is like a cold desert, you require some kind of infrastructure like heaters to keep the water warm. And during COVID, one had to wash their hands so often. So solar water heaters were set up. And greenhouses were set up to ensure food security in such a remote area. So all of this was, something that was pumped back from the community fund that was being taken from the AstroStays. And we've always kind of aimed to link the various parameters around AstroStays very, very strongly to the SDGs. That also helps us to monitor and evaluate where we are, not just in terms of quantitative part. That's really easy because there is a revenue flow and the economic part of it is really easy. But then are you actually helping to create those kind of livelihoods? Is there an empowerment that actually, so the soft benefits and the qualitative part is something that also needs to be monitored, and we really rely on SDGs and link them strongly to monitor that. One of the things that I'm really proud of is that in addition to the solar water and the greenhouse setups that were done, the money that's being generated from the community setup is also now being used by the local women of Man, where the AstroStays have been set up, to actually do handicrafts. So all of these women that you see, they had been trained, and the material and the wool, everything was purchased by the the community fund that was collected from the AstroStays sessions, and now they are actually being sold to travelers who come for these sessions. Obviously, there is no online market linkage for them yet, but people who actually come for the stargazing session is because it's really cold at that point of time. They're just nicely laid out. Another implementation that we are doing this year is we are collaborating with the monastery in Ladakh. It's called Phayang, and it dates back to 1500. Where we are trying to combine cosmology from a Buddhist perspective, just a parallel perspective, and how the Western science looks at it. So we are working with a lot of monks who are actually, so there are different science centers in monastery these days, which are being, the governance is actually done by the Dalai Lama. And we are working with them to see how we can kind of create that experiences that talks about the indigenous knowledge and the Western science. As a next step, we're really excited about the potential of AstroStays. It is not just about science popularization and outreach alone, but what we have seen is that it's also about how you can use science to actually create real on-ground impact. It's about making science more equitable, more accessible, and more inclusive too, for all of these people who reside in remote and rural areas. So as a next step, we are identifying potential communities, again in remote areas. The remote, the better, where we can implement AstroStays, and then working with the communities on how we can implement these projects. So thank you very much. I really hope that you enjoyed this journey to 16,000 feet. And on your screen, you see a picture of one of the boats that we have put right on the banks of the lake that I was mentioning. So this is part of the offline market linkage as well. Thank you very much.
Thanks very much for a very nice talk. I just want to say personally that I visited Ladakh in 2019 to Hanley Observatory, and I saw all of the the new sort of tourist places that have opened up in the Indus Valley. And I can really understand why astrotourism is such a compelling thing to develop there. So thanks for a very great talk. And we're running quite a bit over time, so I'll just ask if there's any really quick questions, and then we should break for coffee and come back here at 22:12. So any questions from the audience? Yes, I see one here, but none here. So Daniel, do you want to ask your question?
Yes, I do. Thank you very much for a great talk, Sonal. It was really an interesting talk. I have 3 questions. I don't know if I'll be allowed because you said 2 just quick questions. But the first comment is that I like it for looking at this for development, rural development as well. It's a good model, and I think we can adopt it here in South Africa. But my first question is, I heard you talking about astro stays and you talk about homestays. Is it just semantics, or is there a difference between astro stays or homestays? That's the first question. The second question was coming to the training. What was more interesting in what you said was that you are taking people that are some were dropouts, high school dropouts, and some didn't even have an education. I want to coin this with the former speaker, Caroline, when he talks about language as well. Then it brought a sense that you must have been able to use the language, indigenous language in that area. But then we also had the concern of incompleteness of the indigenous languages, mostly in science, when coming to science engagement. So I want to find out, how did you go about that in your training, and how long did that training take? Thank you very much.
All right. Thank you very much, Daniel, and very, very pertinent questions. So the first question about homestays and astro stays, the model that we have in MAN has a very tight coupling between astro stays and the astronomy experiences. But that being said, so people from nearby resorts and lodges are still free to walk in and come over for having these astronomy experiences. We do not have that tight coupling in the sense that only people who are residing in the homestays will be able to come over, because there are lots of homestays in the area, but we have only started with 5 because we wanted to start small and we wanted to kind of test waters and see how does it evolve. So we started with only 5 homestays, so to speak, and there is a common community area where the telescope is brought in out every night, and people from these homestays who've been trained in these astronomy sessions, they come over and take these sessions. So that tight coupling is not done. We have people who are coming from even nearby villages or nearby resorts to our astro stays as well. On the training part, yes, it took us a lot of time to figure out, because we were not able to get resources that could cater to the audience that we were trying to train. Something that really demystified astronomy basics to that extent. I mean, there were lots of folk tales and there were lots of basics as well, but because, like I said, the people we were working with were even high school dropouts. So what we did was we were working with a set of professional astronomers, and the language that we usually use in Ladakh, even though Tibetan is something that's widely used, but Hindi is something that the people understand as well. And Hindi, I think, has a huge vocabulary. So we had lots of resources that were kind of tailor-made by talking to the locals as well. So there was an exercise that was done where we went out to communities, talked to the ancestors, talked to the elders in the communities, jotting down the stories that they had, and then whatever relevant information that we could find and patching together was something that we started presenting as part of the workshop. The workshop took around 4 days. It was all theoretical, and then I think a couple of days of on-ground sessions. But what I've really found is, when we started, the training was a big challenge in our heads as well. But the technical part is really easy, is what I found. It really is the cultural and social barriers that you have to break to get a project, which is actually community-led, go off the ground. And the human factors. So you can train people in a certain skill set, but then are they ready to step out of their houses and do these sessions at 12 at midnight? So those that passion and motivation also has to come. So that also is something that you have to link very, very strongly with the training part as well. I hope I was able to answer your questions.
Thanks very much for that. So I'd like to thank you, Sonal, and all the speakers in this session. So we take a quick break now for 10 minutes and back at 11:40. Oh, and Charles has some announcements.
Sister Sally. Yep, I'd like to start first. I think you should start first.
Okay, hello everyone. My name is Sally and I work at the SAO. Today we've got a film crew coming to film part of the conference, AfAS conference, and also to film for a very exciting event, a very exciting film that we're going to be creating. It is the handover film for the IUGA 2024. So I don't know if you've been to a GA before, but remember at those GAs we have a short 4-minute film that's played that celebrates the next country, the next host's astronomy events, as well as the country or the country and continent itself. So we're going to be doing this for the Africa bid, and just so that you're aware, we're going to have these the videographers on site, and we're going to be taking photos. We're also going to be taking videos, and we're going to be conducting short 1-minute interviews. So we'd love to hear from any of you in the audience, just to get a feel for what the IUGA means to you and to your African country as well. And one other thing to note, if you're not comfortable being in the general shots, please you feel free to get in contact with me. I'll put my details on the Slack channel, and we'll make sure that you're blurred out. Okay, thank you. Yeah. Oh, we'll be meeting at the Salt Boardroom. So if you are, and we encourage you to all come and interview with us, do these short 1-minute interviews. We'll be in the Salt Boardroom that's just in the building across the road, and there'll be signs. Yes. Yes. So from lunchtime throughout the afternoon. Okay, thank you.
And by the way, lunchtime is now only 45 minutes, so there's not an hour to eat today. Yep. Yep. And also tomorrow we will be going to the Exoplanetarium. So for those that are staying at the hotel, the transport is going to be provided, and then those that need to come back to the SAO, I think that you can just come and speak to me if you need to come back to the SAO after that event. Thanks.